This video presents the basic mechanical structure of the Alt6502. The motherboard contains the CPU and system memory and some logic. It is attached to the vertically mounted backplane board via a flat ribbon cable. It is possible to add up to 8 expansion boards to the backplane board. They are numbered from 0 to 7 and are spaced 20 millimeters apart. Each expansion board measures 100 by 160 millimeters and is attached to the backplane board using a simple 38-pin header connector. This means that a normal Euro board fits perfectly as an expansion board. The backplane board is supported by a wall, and the expansion boards and the main board are also surrounded by walls. Each of them is 3D printable, and that means they cannot be larger than 20 centimeters in any dimension. Since there is a requirement for 16 boards, there is a need for another backplane board, which is denoted by BP2 here, to support the remaining 8 boards. These boards are numbered from 8 to 15, and of course they also need supporting walls. And there needs to be a lid on the expansion board box, and each expansion board has a small vertical panel. On the front side, the main board can host 4 user interface boards, which are mounted vertically. However, in the architecture we specified 12 user interface boards, and we therefore need an extended motherboard, which is denoted by EMB. Since there is no electronics on this board, it can be populated with the remaining 8 user interface boards. Do you remember the separation between user interface boards and the panel board in the architecture episode? Now it will be obvious why this is necessary. The user interface boards needs to be connected to boards which actually carry the switches and buttons. These boards are called panel boards. To improve the ergonomic feel of the computer, these panel boards will be mounted at an angle which is pleasant for the user and form a big slanted front panel aimed towards the user. This leaning front panel is organized around a grid which has a spacing of 5 by 5 centimeters. Each panel board will fit into an integral number of slots. This means that panels may be 5 by 5, 5 by 10 or even 5 by 20 centimeters. In total there can be 18 5 by 5 panels forming the complete lid. The lid is hinged at the bottom and can be opened. To open it, one uses the 2 small arms and pull the lid out. The lid can be fully opened and the 2 small arms turns into legs which the panel rests on. The panel boards will be sitting on the back side of the front panel and connects to the user interface boards using ribbon cables. When opened this way, the motherboard, the user interface and panel boards are visible and fully accessible in a very tinker-friendly way. Let's have a look at one of the panel boards. That is the plastic holder that fits into the grid, not the PCB itself. This is the front side of the panel that faces the user. The big holes are for the switches and the smaller ones are for the LEDs. This particular panel takes up 2 grid positions and is thus 5 by 10 centimeters. It will take 2 of these to make a total address control and 1 to make an 8-bit data control. One may note that the LEDs and switches are grouped by 4 instead of 3 as in iteration 1. I changed this because my head seemed to be hardwired to hex values, and that 4 seemed to be a nice fit into a single grid slot. I could not make the octal representation look and behave good. This is the backside of the address panel. There are some ears that position and hold the panel into place in the grid, and there are some built-in spacers that will attach to the PCB. The PCB will have a hole in the corresponding positions and will be attached using screws. A preliminary print of the address panel looks like this, and I think it looks pretty nice, despite the ugly white color. Somehow the white color gives the least problems when printing, but I guess I have to paint the whole thing in the end to give it the color and finish I want. The other panels are constructed in a similar fashion. This set of panels will consume a total of 10 slots, so that means that we will have 8 slots left to do some other stuff with. We will continue to develop the mechanics in episode 6, 9 and 10, but this was all that we had for this time. In the next episode, we will define the backplane bus and the expansion board protocol. See you next time!